So we have to keep in mind this information. And if we plug the real part of these formulas, symbolic formulas, we obtain, yes, this equation. But at this point, dissipation, C omega x, acceleration and driving force don't respect the physics of the phenomenon or vectors or arrows direction in the representation you can see in the top left corner. Hence, we must update the equation signs. Okay. So this is the equation once again. We change signs as I propose. And then, because of the complex or symbolic notations, we can write down the equation in these terms, and resorting, we obtain the usual formula. Now, we put everything together, the equation of motion, the symbolic set with minus or negative force, driving force, and the usual substitutions, and we obtain, finally, I must say, both the things I investigated for so long. At denominator, the variable with the highest power is in the right in the first place. At numerator, we have a plus sign that leads us to solving phase 2, the physical meaning. We separe modulus from phase of the frequency response function, and we have this situation. So let's build the diagrams into the three areas: quasi-static, resonance, seismographical, starting from quasi-static. That's the formulas we have used, and that's the diagram for the quasi-static area. Maybe a few explanations. I represented the driving force position line, that is to say this one. Then I drew the negative direction of it as per symbolic substitution, that is to say this one. This is F, this is minus F, this is the angle of the force, this is the phase that adds up to force to draw the displacement, x, the direction of the displacement, which is x. The phase of the force is omega t. While adding phi to it, we obtain the phase of the displacement, and then the three forces are 90 degrees one to each other, are 90 degrees counterclockwise away one to each other because of j equals e raised to j pi over 2, which is cosine pi over 2 più j sine pi over 2, which is equal to 0, più j multiplied by 1, which is j. Then with the same procedure, we study the case r equal 1 and r equal infinite, and we obtain this situation, these diagrams, which are the opposite, of course, because the negative sign, maybe in the next slide, yes, the next slide represents all the three, is the resume somehow of the study. The diagrams are the opposite, the mirrored somehow diagrams of what the current theory states, but they work. And after each one, there's the set of equation in each case. observation, we finally came to the conclusion everything is working fine. The signs, to me, are correct because they suit the swing phenomenon. In fact, force is maximum, driving force is maximum and positive when displacement is maximum but negative. Think at the parent that pushes forward the child when he's arrived at the maximum backwards position. Elastic force, that has opposite sign of displacement, is positive as the drive. In the swing analogy, gravity pushes in the same direction of driving force. Because this is, to me, the key point of forced oscillation and resonance, even in the electrotechnic world. Before resonance, the active forces, that is to say, drive and elastic force, or voltage and capacitance, are equiversed. So energy builds up and displacement, or charges, and velocity, or current, grow till resonance, where phase between drive and elastic force changes sign and becomes negative. So from resonance on, elastic force is braked more and more by driving force as frequency increases. So to me, the fact that beyond resonance displacement decreases more and more is due to this fact and not by the inertia of the mass that can follow the speed imposed by driving frequency. Although this observation has sense too, of course. Though displacement in quasi-static area still seems to give an initial displacement x0 at times equals 0, on the 7th of December 2022, I came to the possible explanation of the starting problem of the swing via an intuition, and I must thank God for that. The very first thrust of the parent, maybe even the second one, but let's simplify, the very first one happens in resonance condition. That is to say, driving force is synced with velocity, which should be maximum as the driving force. But because we are starting from rest, that particular instant is a singularity. Think at it as an initial velocity, v0. But starting from the second cycle, all the resonance conditions are instead met. Maximum force at maximum velocity at equilibrium point. The trick is that from the second or third thrust parent gives to child, parent himself shifts his phase and moves himself from equilibrium point to maximum range displacement position. Otherwise, he would be hit by the swing. So this is, to me, the explanation. The first thrust, and I repeat maybe also the second one, but the first thrust, works in resonance. All the other ones in quasi-static. The proof of concept is that the first thrust amplifies the range of motion. Actually, it transforms zero displacement into non-null displacement. But then all the other ones maintain the same range of motion, amplitude, of the swing, even if drive frequency and natural one are the same, because the phase between drive and elastic force has changed. Another proof of concept is that if parent wants to increase the range of motion of the swing while being not at the equilibrium point, he actually has to exert much more force for the swing to increase range of motion. So basically, to reproduce a frequency response function curve, it should be parent is in max range position, pushing forward when child is at maximum backwards negative position. Then parent moves to equilibrium point and pushes forward when child is passing through equilibrium point, zero displacement and maximum velocity. Then parent moves even further forward and pushes forward when child is maximum positive range position, ready to come back. So that is to say that parent is pushing forward against gravity, but of course in daily experience we have one or two thrusts in resonance and then only quasi-static behavior, of course. Why displacement grows gradually heading towards resonance, you might ask? I think that is due to mechanical impedance, as I'll show you in the maybe next one, but in a future slide, where the conceptual cornerstone is. It's not the infinite response in resonance, the strange thing, but the finite one into the other two areas. I'll explain in the next slide or video. So let's recap all the highlights point in one table. This is the final recap. Instead of that set of equation for the modulus and phase, and the final resulting set of equation of force and displacement, I propose those ones with the negative force that results in a positive variable at its highest power, in an expression of the phase that has sense to me, and above all in the final result, in the final set of equation of displacement and force, driving force, that has the final set that has a physical meaning. I repeat all the swing analogy. Maximum force when child is in against the parent, and vice versa. And visually, via the swing analogy, that's the quasi-static area before resonance, where force and gravity or elastic force, it depends how you want to see the phenomenon, are synced. Force, driving force, and elastic one are synced. In resonance, where force is synced with velocity, and force and displacement are in quadrature. And beyond resonance, where force and driving force and elastic one, or gravity in the case of the swing, are opposite one to each other. And we are done, so feel free to comment or contact me, and because we are on YouTube, please subscribe and click on the notification bell to receive updates on this and other ideas that I come up with, and consider to give a thumb up too, and share, link or talk of this video with anyone that could be interested in this topic. So until next time, stay strong.